Yeah, it makes sense. My dad doesn't. Whatever. I'm done.
Madeline hates her dad.
Yeah, Madeline hates her dad.
Anyway,
I'm just
so
not even gonna fight it anymore.
let's talk about parabolas. I know that last year, most of you guys, pretty much everybody went through some form of conic stuff where we talked about parabolas, ellipses, hyperbolas, and circles. I forgot what the other there was. And what we're going to do here, in lieu of, we had talked about doing some of the probability statistics stuff, but then we realized, well, there's a whole stats class, and it's just kind of like, we can't get enough, there's not enough time to get through all of it. It is fun.
You don't need to know this.
But with this stuff, we'll be able to get through, I think it's only 4 sections, I want to say, of chapter 10. It's like 10, 2, 3, 4, it might even be just a little bit of 5. And then that'll push us to right around, Montana and I were talking, it's going to push us right around the 18th, 19th in that neighborhood, somewhere in here, and be done with conic stuff. And that'll give us about 2-3 days worth of, actually 3-4 days of limits, which will get us into derivatives, which is all we need to worry about for pre-comp stuff. And then that way, then that Friday before Memorial Day, the seniors will take the final, which will have some limited limits and the derivative stuff on there. And then the rest of you guys would take a quiz on limits and stuff that Friday. So that's how everybody would be doing something on that day. For the senior stuff? Yeah, it's truncated to fit the allotted time.
That's dumb.
It's, you might have it written.
No.
Yeah.
I'm thinking about it
It
though.
does not exist. I was thinking about so he and I just quoted Mean Girls over here. It's about limits.
It does not exist.
Yeah, and Aaron got a haircut that week. He looked real good. That was
Parabolas. So when we're talking about parabolas, if you guys recall from last year, we actually did some parabola stuff earlier in the year too, where we were graphing things out of standard form. We did some graphing standard form stuff where it was y equals ax squared plus bx plus c, where we would get that axis of symmetry, is it up like a cup, down like a crown, and do all that other stuff. Get the vertex and go. Well, there's another way to go about doing this, and that's using the standard forms of a parabola. Now, when you have the standard forms of these equations, we're going to center everything at the origin to start, then we'll start shifting things. And we're going to do that with all 4 of the conic sections. We'll do that with parabolas, because remember, parabolas can go up or down, but they could go sideways or that. No, those are still parabolas. Okay. These are your x squared parabolas that are up like a cup or down like a frown. These are your y squared parabolas that are left and right. Vaguely remember that from last year then? So then same deal, we'll talk about those. We'll talk about an ellipse. An ellipse is a stretched circle, if you will. It goes up and down, or it's going to go left and right. Then we're going to talk about the circle, which is an ellipse that's not been squished. What's that? Right. An ellipse is a circle. And then the last one is going to be the hyperbola, which has this. I don't know how in-depth you guys got by doing all this. You guys remember doing all that? Slant asymptotes and stuff. And then we do that left and right as well.
Yeah, I'd like to do anything.
The other thing that you're going to see quite often with these things also is completing the square. Do you vaguely remember what it meant to complete the square?
Yeah, you have to split the middle term, then square it, and then put it in the black spot and on the other side.
Nice. Pretty close to the shape. So just for a quick refresher, let me show you guys an example of a complete square real quick. Completing the square is a way to factor something when it's not factorable. X squared plus 10x minus 3 is 0. It's another way to do it. It's another way to set this up and go. And it's just like, well, here, Daddy, you do it. I'm going to go have a sip of coffee.
Oh gosh.
I'll take notes for you.
15.
So, you split this 10, so 10
Did you know they bought the movie? Did you see that?
10
Did
divided
that limit exist?
Oh shoot, okay, 10 divided by
His
2.
tie doesn't match his shirt.
Okay, I don't believe that I'm that loud.
You're pretty loud.
Okay, time.
Do you know what's going
okay.
on in humanities?
Equals 5. I don't think I've ever talked about humanities.
Wait, why do you divide it by 2?
Because you're splitting it.
Splitting what?
2.
The middle term, I said that earlier. So then you square it, and you get 25, and then you put the 25 over here.
Why?
over there.
What?
Free.
Yeah,
And
what
the-
about 3?
You move the 3 over here, so then you get 0, so, 0. So then
So
you
you-
get, like,
I still confused why you divided by 2.
you can get to split the
That's
middle
just
term
what
in
you do?
half. Yeah, that's just what you do.
28.
Then you just, I don't know, you split it in half.
Hold on, let me
still.
check my Twitter.
Ooh.
Okay, so then you get x squared plus 10 x. No, yes, I'm a little lost now. And then plus 25 equals 28, and I don't think this, it is right? Oh, okay, sweet,
The limit
okay.
exists.
So you move this 25 over here. No, just kidding, you don't do that.
You're gonna get right back to
Move the 25?
1 times 1's 25, you had to get rid of 10.
Oh, 5. So you get x plus 5 and x plus
squared.
5.
Is that
Okay, yeah.
first power?
Yeah, sorry.
Good
Okay.
question, Mark.
But then, like, since this is the same thing, you can just do x plus 5 quantity
Oh,
squared.
nifty.
Yeah, that's a really nifty math trick.
That looks like that.
But the problem is there's still this 28 over here, and I forgot what you do with that. So-
What do you do with that 28?
Equals 28. But, nice. So,
Start throwing stuff at
Get a better arm.
okay, help me, what do you do? Neither of you were anywhere close.
Oh! What'd you do,
You
Madeline?
broke the damn computer.
Okay.
you. Give something more.
Oh, shoot. Okay. We have to, okay, we're in math class right now.
Are we?
So, what do we do? You guys are bad students. I'm writing you all up.
Bet you won't.
Bet you won't.
That I will.
Are you scared?
So, wait,
Really?
what do you do? Anybody know? Wait, no, sit down. I'm calling on the students. Sit down.
Wow. He's just trying to sharpen his pencil.
You go.
Yeah!
X plus 5 equals
No, I don't think so. Okay, Jack, Colton, Mark, you're smart.
No, we're not.
You're smart.
Don't assume.
Okay, well, obviously Colton's smart if he's in
No,
here.
wait, solve for X.
False statement.
So,
that's
all right,
Just square root
so
both sides.
as a concerned citizen of the group,
I agree.
I'm going to help explain what this guy's trying to teach us, because I'm going to be the voice of reason and explain to you exactly what I mean.
All right, go right ahead.
Okay,
The
well,
reason why we're doing this,
Where's the voice coming?
Well, now I'm just confused.
I was trying so hard to imitate this. Not working. The reason why we're doing this is because we need to do this in this section.
But for what reason?
Murphy, when's the test going to be?
So this is one of the topics we've all learned.
Can we have a note card on it?
How are your kids?
I am so done.
okay, no, I got
You're doing
this.
fine. All right.
Why did
Anyway.
you say that?
This is, why are you guys throwing stuff at me?
We just
Says the one who threw things at me.
It wasn't me. It was Maddie.
joined in.
Yeah. Okay, what do we do?
Pretty floppy.
Thanks. doing so much.
He turns magician.
Anyway, so the reason why we go back to completing the square is one of the ways that we have to look at setting up
It's
conics.
just wasted paper. This school doesn't recycle.
Was it really a waste?
No.
They didn't even hit me, so yeah, they were a waste.
Still funny though.
You know, Murphy, I don't like it when you write this big on my papers.
I'm taking notes.
Continue.
Anyway, the reason why we're going back and looking at completing the square is because we use completing the square.
It was fine. I was just moving it.
Really?
So we use completing the square all the time. And the reason why we do complete the square is because sometimes you're solving for x. Because you can solve for x here by just taking the square root of both sides. And you're going to get x plus 5 is plus or minus the square root of 28. So you could solve for x that way. This is another way of solving an equation. A lot of times with completing the square within conics, it's going to allow us to figure out what style conic it is by setting it up into one of the four main standard forms. We haven't talked a single thing about any of the standard forms yet, but there's going to be 4 of them. Parabola, ellipse, circle, and hyperbola. Technically, there's 2 different ones for the parabolas, 2 different for the ellipse, 2 different for the hyperbola, but I'll go easy on you. There's only 1 for the circle.
Oh, really?
So there's, yeah, in a roundabout way. Now, what happens,
Okay, so that's just the insert 5 plus.
yeah, it'd be x would equal negative 5 plus or minus 2 root 7.
What?
It's the square root of 28.
X.
Wait, -5
But remember,
plus minus.
That one never
What the main goal of completing the square of this unit is not to just solve for x. The main goal of completing the square for this unit is going to allow us to take something that's written out in this giant standard form of an equation and figure out what shape it is. That's all I was just trying to remind us of. That's all. Don't worry about solving for x. Just the process of, like she said, when you have a setup, you take half of b. Half of b always drops into your parentheses. It's always the term within parentheses. If this was x squared minus 10x, what's half of negative 10? Negative 5 would have dropped then. When you square it, that's what you're adding to both sides. So you take half of your b term, drop it to the parentheses, square it, add it to both sides. That's how you're able to come up with a perfect square trinomial. That's the process. We utilize it a boatload with these things. Just a quick little refresher. Thank you.
You're so welcome.
I'm getting better with my tone.
That was legit.
Oh my.
Not too legit.
I wasn't joking.
Did you see the MC Hammer's in a commercial now? He's old.
For what?
I couldn't
Yeah.
even tell you what MC Hammer
That's
was.
what time does. Can you pull it up?
I'm busy. So you have 2 generic forms of the equation for standard form of the parabola. We have one where we have the shift, and we have the one where it's at the origin.
I like the origin ones.
It's very quick. Because when you're looking at a parabola, let me just write up these 2 formulas here. I think today let's just worry about the non-shifted stuff today. And we'll go back to the shifted stuff next week. When you're dealing with a parabola, you're going to have an x squared parabola or a y squared parabola. When you look at a parabola, it's either going to be up like a cup or down like a frown. X squared parabolas are always up like a cup or down like a frown. If it is up like a cup and centered at the origin, that is the center point. The vertex itself, for all of these different conics, the vertex is always looking towards what's called a focus. The focus is somewhere inside the parabola. It's something that it's looking at. If you start thinking about how glasses are made, the curvature of the glasses, they're all parabolic, plus or minus. There's that curvature where it's allowing, because the way that the light refracts into your eyes and goes back and forth, it's trying to adjust for the compensation to make it technically focus. That's how glasses work. So what happens here is you have what's called a focus. It always looks towards it, and behind it is a balancing part. It's called the directrix. The focus and the directrix are equidistant to the center. Okay? These two distances are the same. They call this distance P. Vertex to focus is P. Vertex to directrix then would be opposite of P. All right? What? You all right? Okay. So a lot of these things, when we start to look at them, if it's an x squared, what's the example of this? It's x squared equals 16y, and we're going to graph that. This is going to be centered at the origin, and the reason that it's centered at the origin is that there's no h and k. And we're not going to worry about h and k today. I think it's too nice out to worry about things like that.
I think you're right.
We're supposed to be reading all these.
We'll have to worry about it eventually, but you know, for right now. So, it being an x squared equation, and that, nice save. Being an x squared equation, and the 16 value is positive, which direction should this open up? Up. Like a? What? I just haven't made it yet. That's why. Okay. So what we do here is, we know that our graph is going to be centered at the origin. We know it's going to be opening upward. What we need to do is figure out, excuse me, what our p-value is. Since it's an x squared parabola, this 4p value has to be set equal to 16. So where's our focus going to be at? It's going to be at 0, 4. So our focus is going to be at 0, 4. And now our directrix, what's the equation of the line of the directrix? Ooh, it's y equals. And that's the trick here. If you have an x squared parabola, your directrix wants to slice through it. So it's going to be a y equals. If it's a y squared parabola, x wants to slice through it. It's going to be opposite of the square. Does that make sense?
Yeah.
It's a quick, easy way to remember. So it's going to be y equals -4. And you could get really fancy if you want, and substitute values and go through it, but it's basically this. Not really, because we'll get in, as you get further along with the parabola stuff, and especially with the shift, it becomes easier to balance how big and how small things are out there.
Another crazy one. Not a lot of. It's crazy here.
I'm really bad at parabolas.
Good. And do I need to write all this out?
It's just that one right
All right. Let's find the equation of the parabola, vertex at the origin, and the focus is at 2, 0. Vertex at the origin, focus at 2, 0. The easiest way to figure out what kind of a graph you're dealing with, whether it's x squared, y squared, opening up, down, left, right, is to plot it. Plot your 2 points that you know. I know where the vertex is. And I know where the focus is. Where's the focus? To the right. So if my center is at the origin and my focus is to the right, which way am I opening? To the right. To the right is what style? Y squared. So I know this has to be a y squared equals 4px. Well, my p-value is the distance from my center to my focus. What's p? 2. So what's my equation?
How did that happen?
It's called gravity.
Well, I was writing and I didn't see how you dropped. Like where you, I thought it was in your pocket.
Negative 9.8 meters per second squared is a yard. Yeah.
That's pretty good.
I had it behind my back and I scratched and I bumped the tray and it just fell out of my hand because I didn't really know what it was.
Oh, okay. That's what I wanted to know. Okay, don't look at me like that.
When do you want to teach you guys? I got more material.
I can teach anytime.
Find the focus of a parabola. Let's see if we can figure out where the focus is. We had the equation, and I'm sorry, it was a little fuzzy. Y equals negative 1/2 x squared minus x plus 1/2. And I need to figure out where the focus is. So, who likes fractions?
Not me.
Can you easily complete the square when your lead term coefficient is not 1 though? No. In other words, don't do that. Always complete the square when your first term is going to be positive, like a positive 1, because it just becomes a nightmare otherwise. So how can I make that x squared term 1? Negative 2. I'm going to multiply everything by negative 2. So we get negative 2y is x squared plus 2x minus 1. Now we're trying to see if we can figure out where our equation's going to wind up. Oh no, did this mean that we wound up at a shift? Oh yes, it did. So should we write down the equation really fast just in case we need it? Yes, that's a great idea. Yeah, we kind of have to. Yeah, I'll go back. So real quick, as we go back to the standard then, where's this one? When we look at, and I'll just bring over to this same spot. So when you have the shifted version of a parabola, you're going to have either, it's still going to be an x squared or a y squared. It's just going to be the quantity x minus h squared equals 4p y minus k, or y minus k value squared equals 4. Where this p-value is still going to be the distance from your center to your origin. Where your origin, when you have a shift, is going to be located where and where? Not at the center, but where and where? H and K. Your center is going to be at H and K. Yeah, vertex center, excuse me. I'm already thinking of like ellipses and stuff like that. That's the center. It's not the vertex and stuff. Sorry. So what I'm getting to this here is this is the case that we want to make the complete the square. This is the idea where we want to get the quantity squared with the x squared stuff in one side. So when I'm looking at this problem now, I have the x squared plus 2x minus 1 on the right. I got to move that constant. How do I move a negative 1? Add it. So I'm going to get negative 2y plus 1 is x squared plus 2x. Everybody okay with that? Personal preference here. I like to do my complete the square stuff when my square term is on the left side. So is it okay if I flip-flop left and right? Those of you guys that had me before when we completed the square, why did I put the blank? So I never forget, right? Because when you complete the square, you're taking half of b, square it, and you add that to both sides. This, by putting this little blank spot, will force you a little bit to remember that I gotta complete the square, which means I have to add in something to both sides. I bet you left the purse.
I did. Where is it?
Did you?
Where is it?
I don't know.
What the heck, man?
Joe.
Oh, you got it? Okay. Hello.
Guys, this is Joy. You know Joy? She forgot her purse, and I think Maddie. She's so rude.
That was kind of rude.
Maddie, do you have that $7? No. See you, Joy. Have a good weekend.
You too.
This is the idea where we go back to completing the square. What's half of 2?
Half of 2 is almost a miracle.
So that 1 value is going to drop here. When I square it, I put it here and here. So Maddie, my notes make sense why I drew those arrows?
Yeah.
So now I have an x plus 1 quantity squared, and that other side is going to equal negative 2y plus 2. It's very close to getting into the standard form of the equation, but remember, the standard form of the equation has the y minus k within parentheses, which means I got to take out a GCF to pull it out of it. Want to take out a 2 or a negative 2? Take out the negative 2. Where is the center of this parabola located? Third time's charm? Negative 1 and 1. My h and k here is at negative 1 and 1. So my center is going to be at negative 1 and 1. My p-value has to equal, or excuse me, my 4p value has to equal negative 2. What's my p-value going to have to equal? Negative 1/2. So now you have to start thinking. When you have a parabola that's an x squared who is located at negative 1 and 1 from the origin, which means it's going to go up or down, the p-value is negative. Which direction is this opening? X, it's opening down because it's x squared. And the distance from the center to the opening is 1/2 away. Where is that center? Negative 1 and 1/2. That's how these things work. That's how these things work as we go through. That's about as goofy as any of this gets for today, I think. Okay. Now I realize this, I'm looking at the algebra 2 book. It's not algebra 2.
Still.
Probably make sure I get the right material for you guys. Math doesn't really change, it just gets a little bit more complicated. Yeah, that's good. Let's do this.
He's in the right form. Enjoy the weekend.
I could, but I could also say, comma, do these.
Why don't you switch them?
Yeah.
That's not how I wanted to do.
As you erase and rewrite it, how's that safe and light? But you just wrote it.
George did that.
And then you rewrote it.
Yes.
So
You used
even more than that.
Yes,
So if you put your card in reverse and the miles come off the odometer,
Yeah?
Because he's all like, yeah, look over, you can see the.
Why didn't you kill him?
Why is everyone so mad at each
Because
other?
they were.
Because
I'm not mad at anybody. I'm happy.
Killed people.
I'm always happy. Right,
Killed the
Stinky?
girl. So he killed
Yeah, you're right.
him. So he's put him out of his misery before the other people die. I'm talking about you, Mike.
Really?
Three children.
Kind of blow up my